In this video, we're going to discuss time, how Nuke works with time, and also how to time warp. Time warping allows you to alter the duration of footage so it becomes slower or faster. As a demonstration, I have this Maya render here. Let's take a look. It's broken into two render passes. The first one is read into read 1, and that's simply this red blob or sphere. The second render pass is read into read 2, and that's the background, the ground, and the sky. Those two renders are merged together with the merge node. Let's take a look at the duration. The renders themselves are 30 frames long. I can tell that by the original range, 1 to 30. You can see the frame range is also set to 1 to 30. The timeline is actually longer than 30 frames. So what happens there is once the timeline gets past 30, it simply repeats the last frame. Frame 30 is repeated over and over and over, and that's caused by the hold menu right here. Read 2 is the same. This footage is 30 frames long, and the last frame is held once the timeline goes past that. The timeline itself runs from frame 5 to frame 70, and that's because you can choose a range when you set the project settings. Let's take a look. Edit, Project Settings. You can see here frame range 5 to 70. That's what the timeline picks up. The project settings are also set to 24 frames per second. That means that any image sequence that's read in is interpreted as 24 frames per second. The timeline itself is also set to 24. This desired playback cell here determines what frame rate the timeline attempts to get to as you play back. Because I've entered 24, when I play back after the renders have been read into RAM, it'll play back at 24 frames per second, or at least very, very close. So we have footage that only runs 30 frames and is interpreted at 24 frames per second and plays back at 24 frames per second. So let's talk about how to warp that. There are different ways to time warp inside Nuke. A really great way to do that is through the OFlow node. OFlow uses optical flow technology to plot the pixels within an image. Because we have two renders though, we'll really need to use two OFlow nodes to get the best result. Let's just start with the ball. I'll select that, right mouse button click, and go to Time, OFlow. It'll start to work right away. Now the speed of the warp is controlled by speed. By default, it's set to 0.5, which means that the footage is twice as slow or half as fast. Any number below 1 here causes the footage to slow down. Any value above 1 causes the footage to speed up, and 1 is no change. So let's say I want to slow this down so it's only 66% of its original speed. I can enter 0.66. In order to slow down footage, it has to create new frames in between as it stretches it out. Again, it's using the optical flow technology to plot the motion of pixels in that image sequence and use that information to synthesize brand new frames. It's so good, in fact, it's difficult to see where it's done that. One trick to see what's going on, though, is to change the method. By default, method is set to motion, which again uses optical flow. If you switch this to blend, it will use a simpler method. You can see that it simply overlays surrounding frames with semi-transparency to create a new in-between frame. It's very fast, but very crude. If I switch back to motion, you'll see that the new in-between frame is very nicely blended. There is a third method which is even simpler, which is called frame, where it simply repeats frames. We'll stay with motion. Motion is by far the best. Now once you're on motion, there are different ways to adjust that. For example, you can show the motion vectors the node is creating by clicking on Show Vectors. And there they are. Each vector is a short segment of a motion path that represents the motion of a pattern of pixels. The pattern might be a single pixel or a block of pixels. Depends on your settings. You can alter how the vectors are working with these last three parameters here. The block size affects how it divides up the image. A large block size will cut the image into larger pieces where each piece has a distinct vector field in it. I'm just going to set this to 3 for this node here. There's also the smoothness parameter. A large smoothness value will concentrate on large detail, large motion, and ignore some of the local small detail, whereas a small smoothness value will do the opposite. I'll go ahead and set the smoothness to 0 so it concentrates on the local detail. There's also vector detail. Vector detail determines how many motion vectors are in a given block. If the value is 1, then there's 1 motion vector per pixel. If the value is below 1, then a motion vector is distributed amongst several pixels, so a larger pattern is being tracked. zero point 0.2 is fine for most scenes. Higher values will definitely slow the node down. For now, I'm going to turn off the show vectors, and then also apply OFlow to the background, and then play it back. Here I'm just going to copy this first OFlow, Control or Command C, click off, Control or Command V, and then place that in between the B pipe and the read to node. Because optical flow is a fairly complex algorithm, it's going to take me a few seconds or minutes to render this out. So I'm going to skip ahead and come back once it's ready to play. Alright, we're back and the timeline is played. Let's see what the result is. So the sphere warping looks pretty nice. I can't tell there's any brand new frames in between that have been created. However, there is some strange warping below the sphere, and that's a product of the second optical flow node. It's not necessary for me to have the same settings on each OFlow node. In fact, different types of footage often require different settings for the maximum quality. For example, on the second OFlow node, a small block size might not be good for the ground. The ground is very noisy, very detailed. Perhaps it's concentrating on so much local detail that there's jitter occurring underneath the sphere. What I can do then is raise the block size. I'll try 25. Because my block size is going to be so much larger, I can go ahead and try to raise the vector detail. So 1 for vector detail. Let's play it back and see how that looks. Again, I'll skip ahead and show you the result once it's played back. It's playing now. You can see the ground looks much, much better. So there we have two OFlow nodes on two image sequences. They're slowing down that footage to 66% of its original speed. You can't really tell that there are brand new frames that have been inserted in between. So that's slowing down. Now let's work on speeding up. In fact, I'm going to come back and show you a network that's set up for just that task. Okay, I'm back with the version where the footage has been sped up. If we look at the OFlow nodes, you can see that the speed is set to 3 on each one. That means that the ball is moving 3 times as fast. Let's play it back. So there's the faster motion. You can see that the sphere reaches the ground much sooner. And because the footage ends much sooner, more of the timeline features a frozen last frame of the sequence. One problem with speeding up footage is the lack of motion blur. If you start with slow footage and speed it up, there should be motion blur because the object is moving faster, but the problem is the original render never contained that much motion blur to start with. There's a way to produce motion blur right through the node though, and that's by using the shutter parameters. With this setup, the automatic shutter time has been selected. That means a Nuke selects a shutter time based on how you warp the footage to try to create a motion blur that's appropriate for the current speed. As long as the shutter samples is above 1, Nuke will blend together a number of in-between positions for the footage to create that blur. You can see it right here. Right now it's set to 32 samples, so there's a bit of a blurry motion blur trail. You can see it on different frames. The higher the shutter samples, the more refined the resulting motion blur because more steps are used. In this case, 32 is fairly good, although it could go higher to make it even better. Now the higher this goes, the longer it takes to render each frame. If you choose not to use automatic shutter time, you can also input your own shutter time beside that parameter. So speeding up is just a matter of increasing the speed value, and then if you choose to, adjusting the various shutter parameters. So you can see how OFlow is able to slow down and speed up. Even though OFlow might slow down the render, it can create a very realistic result. And in terms of time warping, it's a very valuable solution.